Hello, my name is Ksenia Vulikh and I'm a PhD student in the Dr. Jeff Coswell Law of Pathobiology Department at the University of Guelph. My project is about the role of Mycoplasma bovis and the role of copathogenic factors in the pathogenesis of Mycoplasma bovis pneumonia. As you probably know, Mycoplasma bovis is a bacterium that causes lung disease and lameness from arthritis as well as otitis media, conjunctivitis in fetal dot cattle, and mastitis in dairy cattle. The pathogenic mycoplasma causes great economic damage associated with decreased milk production because of mastitis, reduction on daily weight gain because of pneumonia and arthritis in calves, as well as costs associated with animal death and culling. Additionally to those costs, economical damage includes various expenses for drugs, implementation of diagnostic and control measures, labor costs, etc. Also, it is well known that the pathogenesis of M. bovis bronchopneumonia involves damaging bovine macrophages, leading to the development of a very specific form of damage to the lung tissue that we call caseous necrosis. It is very important that this form of lesions is very different from the lesions caused by the other well-known BRD pathogens, and it is very important because we think antibiotics can't enter the damaged tissue, and this is one reason that calves with Mycoplasma pneumonia don't respond well to antibiotics. However, previous experiments had not been able to demonstrate the ability of M. bovis to kill macrophages in vitro, indicating that M. bovis may need additional inflammatory or copathogenic factors to incite M. bovis to damage macrophages. While many animals can carry M. bovis and not show any clinical signs of disease, many studies have found that lungs with typical M. bovis lesions are often co-infected with Mannheimia hemolytica, Pasteurella multosic, Histophilus somni, and other bacteria, which are isolated from almost 80% of the cases and exhibit both caseous necrosis, considered specific for M. bovis, and other types of necrosis, for example, coagulative necrosis, which is specific for Mannheimia hemolytica infection. These findings suggest synergism between those pathogens. So, our hypothesis is that M. bovis needs additional copathogens or an inflammatory process as the initiating factor to cause bronchopneumonia and induce caseous necrosis in cattle. Objectives of my project are seeking to understand how host pathogen and copathogen factors contribute to the pathogenesis of M. bovis bronchopneumonia, and also to identify the mechanisms that allow M. bovis to damage macrophages in vitro and in vivo. Our in vivo part includes the experiments with 1 month-old colostrum-deprived calves, which we raise in our isolation unit with no any contact with dames, so they don't have any antibodies to typical BRD pathogens like Mannheimia hemolytica, Mycoplasma, and others. On these experiments, we try to find out and prove the ability of Mannheimia hemolytica to incite M. bovis to cause bronchopneumonia with typical caseonecrotic lesions, even in case of subsequent antibacterial treatment after 10 days of antimicrobial treatment. So we use the group of colostrum-deprived calves and challenge them via intratracheal bolus with only M. bovis or only Mannheimia hemolytica, or both M. bovis plus Mannheimia hemolytica respectively. Starting from the day with the clinical signs of BRD appear, it's usually approximately about 24-48 hours, all the calves will be treated with Ceftiofur antibiotics daily for 7-10 days until the clinical signs of BRD disappear. After that, calves are observed during next 2-3 weeks, and they are euthanized at 14-18 days after infection, as we consider this time is quite close to the natural way of disease development, and so it should be enough to develop bronchopneumonia or the typical lung lesions specific for each pathogen. Postmortem evaluation of lung and other lesions, if presented, is performed. Expected results are the lung tissue from the calves challenged by both pathogens should have no or minor lung lesion specific for Mannheimia hemolytica infection, but at the same time, the prevalence of chronic focal casionic lesions typical for Mycoplasma bovis. While animals received either only Mannheimia hemolytica should have only lung lesions or very low level of lung lesions typical for Mannheimia hemolytica, and the animals received only M. bovis should not have any lung lesions for these animals. We use various bacterial strains and concentrations in our experiments to find out if also strain or number of exposed bacteria are playing any significant role in the development of casionic lesions. I hope my research will prove that the inflammation may predispose Mycoplasma to develop casionic lesions in the lungs, and then the protocols oriented to prevention of any kind of inflammation, as well as methods to control inflammation caused by other forms of BRD, could be designed and recommended for use in the beef production. As the famous ancient Hippocrates said, we're what we eat. That's why the research and prevention in the area of bovine industry is now very important. Cattle are main source of meat and dairy in the contemporary world, and we're interested to raise healthy cattle using as few drugs as possible, which emphasize the importance of disease prevention approaches. I hope my PhD research project will have a great impact for future effective prevention of respiratory disease in cattle. My project received funding from Beef Cattle Research Council, Ontario Minister of Agriculture, Food and Rural Affairs through the Ontario Agri-Food Innovation Alliance and NSERC. Also, I want to thank my advisor, Dr. Jeff Coswell, members of my advisor committee, Dr. Patrick Borling, Dr. Brendan Plantner, Dr. Jose Perez Casal, and all members of our lab for their help. Thank you very much.